Okay, we have two students having a discussion at lunch. I'm sure you guys do this all the time about the Rutherford gold foil experiment. They're interested in understanding how an alpha particle could be deflected backwards by a gold nucleus. They both understood that the alpha particle can have reasonably large velocity and wanted to see how close the alpha particle could get to the nucleus before being deflected. Before are the summaries of each student's discussions. And you might guess it, you're going to have to critique both. Student A, the alpha particle is positive and will approach the nucleus of the gold atom and then be repelled away after it gets close enough to the nucleus. This is due to the fact that electric potential of the alpha particle is completely converted into electric potential energy. Below is a graph of the beginning velocity of the alpha particle at infinity versus the closest distance r that the alpha particle gets before being deflected. Observe the graph as a straight line indicating a direct relationship between the beginning velocity and the closest distance. And you can see what that graph looks like right there. All right, let's see what madness student 2 has. Student 2. The alpha particle is positive and will approach the nucleus of the gold atom and then be repelled away if it gets close enough. Sounds familiar? This is due to the fact that kinetic energy of the alpha particle is completely converted into electric potential energy. Below is a graph of beginning velocity of the alpha particle at infinity versus the reciprocal closest distance 1 over r that the alpha particle gets to the gold nucleus. Observe that the graph is a straight line indicating a direct relationship between beginning velocity and reciprocal distance. Okay, so there's their straight graph. All right, let's have some fun and critique it. All right, student A. Student A is definitely correct. The alpha particle does get repelled by the gold nucleus. What's incorrect? Electric potential is a measure in volts and cannot be equal to a potential energy. They're close. Not quite though. Remember, you got to take Q times V to get potential energy. Incorrect. The graph of volts versus radius does give a curved line. Why is that so? Volts versus 1 over R would have given a straight line, not volts versus R. Next, student B. Let's take a look at student B. Correct again, the alpha particle does get repelled by the gold nucleus. Correct, the kinetic energy does equal the conversion into electric potential energy. However, the graph of V versus 1 over R, gives a curved line. Why is this so? Well, let's take a look. We know that kinetic energy is converted into EPE. So 1 of mv squared equals kq divided by r. Now what are we left with? We're left with v squared equals 2kq, over m. And then we have another little q in there, times 1 over r. So this will not be a straight line because it's not graphing exactly what the equation says we're supposed to. We should be graphing v squared versus 1 over r to get a straight line graph. And there's my rest of the explanation of it. So I think our students did pretty well this time, but they missed something both times. All right, that's it for our review, and I'll get these posted soon.